Hello everyone and welcome to my channel. I'm here with another video from CCDE series, and in this video I'm going to speak about OSPF to ISIS migration steps. There are 6 steps which I'm going to take in my sample topology, and I'm going to show you how we can do this migration very smoothly without any problem, without the loss of connectivity in the network, and without any downtime. So what I'm going to do first of all is to go through some specific details. For example, I should know that ISIS has higher administrative distance than OSPF. This is very good. What I have in my network is a flat area 0 OSPF network, and this is my network, as you can see. And I have the core of my network here. This is the core of my network. This is the last part of the network which is going to migrate to IS. So basically what I'm going to do is to start from the edges, router 8, router 9, and router 10. These are my edge routers, and they are going to have the first migration, and from that time on all the routers gradually toward the core are going to change into IS. And finally I'm going to remove OSPF from my network. So these are the steps. The first one is going to be to verify the existing platform. Let's do this. What I'm going to do here is I'm going to show IP route OSPF, and you can see that in my network I have connectivity. Full connectivity is here, and based on the loopback interfaces and the network interfaces that I have in my OSPF routing network, I have full connectivity, and all of them are intra-area routes. You can see that because I have just area 0 configured on my interfaces, so I do not have more than that. Let me increase the size of my command terminal so that you can see more of that. And then let's try the connectivity. So what I'm going to do is to do a ping from router 3 or from any other router to other routers. For example, I'm going to go to 9999, and I'm going to source it from, let's say, loopback 0. So you can see that the connectivity is there. You should do this on all routers, and if you have multi-area switches, multi-level switches, multi-layer switches, you can do that on your switches as well. But what I'm doing here is just to show you that the connectivity is there and there is no problem. The next step is going to be to deploy IS over the entire network. I have done this step before, of course, and I have done this because, like I said, IS administrative distance is higher than OSPF administrative distance, so whatever I do, it is not going to install any route in my routing table without any problem. But let's say that you wanted to do EIGRP and you wanted to migrate from OSPF to EIGRP. You know that administrative distance for EIGRP is 90 for internal routes, but for OSPF it is 110. This means that in the beginning of deploying EIGRP, what I needed to do is to raise the administrative distance to something over 110 to make sure that EIGRP is not going to install any route in the routing table. So if I just show IP routing table, you can see that I only have OSPF route, local routes, and connected routes. I do not have any IS route. And I have done very simple configuration of IS. So if I just show run section router IS, you can see that I only have one network and only one area 1. The whole network, of course, is configured area 1, and IS type is level 2 only. Of course, I could just omit this and I could have L1, L2, but because I do not really need anything, L1, L2, and I do not have any edge router, so I do not really need it, L1, L2, so I just configured the whole network as one flat level 2 network. And these are, of course, they are for the interfaces. So if I just say, let's say, I would say section router or interface. So you would see that this would be, let's find it. Okay, this would be my router ISIS configuration. But the rest of the network, of course, I have the interfaces under ISIS, and of course OSPF network. I'm going to remove this configuration later, but you can see that ISIS is configured under all the interfaces. One command that you can see here, CLNS-MTU, I have reduced to CLNS-MTU. That is because I have switches on my way. The normal CLNS-MTU is 1497. I needed to reduce this 1 or 2 bytes just to make sure that when this goes through the trunks, it doesn't really increase the 1500 by adding the trunk, let's say .1Q or ISL header. And for that I just reduced it to 1450. This is not necessary if you can increase MTU on your switches. So this is what I have, and some more verification commands such as show, let's say, ISIS neighbors. You can see that I have router 3 and router 9 as my neighbors. If I just go and check the topology, router 10 is connected to router 3 and router 9 as neighbors, and the neighbors are only level 2. You can see that the type is layer level 2. Of course, you could do show CLNS neighbors as well, and again it would show you basically the same output without any problem. Show ISIS, let's say database, for example, would be a good command to do the verification. You can see that these are all the LSPs that I have received, and I have LSPs from almost all routers in my network without any problems. So I almost have all the information in my network. And also show ISIS. Let me see if I can have more information about that. So show ISIS route. Of course it doesn't have anything because I have not installed anything in my network. Show ISIS topology. Again, shows me some information about the topology of the network. So this is almost everything about ISIS configuration that I have. Now what I'm going to do is to move from OSPF to ISIS, and like I said, I'm going to start it from the edge of the network. So for this, the third step is going to be to change OSPF administrative distance, because ISIS is not going to, I'm not going to change the administrative distance on ISIS. So OSPF administrative distance is going to change, and I'm going to start right from the edge, router 9, router 10. So I just go to there, router 10 right now. I'm going to go to configuration mode, router IS to IS, and then there is a command that says, here it is, distance. So I'm going to change the distance, and it should be something, not of course this. Let me go back to router OSPF. I just wanted to show this one, and here is the stance, of course, the same thing. And I'm going to change the distance for OSPF to something higher than 115, which is administrative distance for ISIS. So let's say I'm going to make it something like 150. Okay, so now that I have done this, ISIS is going to take over, and it is going to install all the routes in the routing table. So if I just show IP routing table, we can see that I have ISIS routes instead of OSPF, and I have everything because right now ISIS is deployed in the whole network and has full information of the whole network. So although I have just moved one of the routers, you can see that I have everything in my routing network, routing table. And if I just try to ping, let's say for example 5555, the ping is successful. If I just source it from some other interface, again there's going to be no problem. So let's do this on almost every other rudder. Rudder 9 is going to be the next one. So I'm going to say rudder OSPF 1, and then I'm going to increase the distance to 150, and then I'm going to show the result. So show IP route. Again, it will show you that ISIS has taken over. Now let's use this commands. Let's say that I am doing this gradually, and I'm doing this on all rudders, and I go toward the core. So now that I have done this, I'm going to go to rudder OSPF 1 on all rudders, and I'm going to say this stance is 150. But you should do this gradually. I'm just doing this suddenly on all rudders. You can see that all rudders now have changed to have reverted to, you know, ISI. So let's say, for example, my core is going to be 1, 2, and 4. If I show IP route, you can see that now ISIS is in my whole network. Next step is going to, you know, check to see if there is any leftover from OSPF. So what I mean by that is I need to make sure that there is no OSPF route in my routing table, and fortunately there is nothing. So if I just do show IP route and check it in my routers, there is nothing here. On router 1 I see nothing, and router 3 I see nothing. I just want to make sure that there is no leftover from OSPF and everything is totally ISOS, and I have full connectivity to my whole network, full information about my whole network. And the next step is going to be to remove OSPF from my network. Now that I have done this, I need to type no rudder OSPF 1, and it should do without any problem. Now you can see that my neighbors are down because I do not have anything. So I'm going to say to show IP protocol on all my devices. I only have ISIS. That's it. Here I only have ISIS. Here I only have ISIS, and I need to check all my routers to make sure that I only have ISIS. There is no OSPF. And do I have any command relating to OSPF or not? Do show run include OSPF, and here I have something like IP OSPF network point to point. I'm going to include OSPF and interface. So I have this interface loopback, so I'm going to just say no IP OSPF network point to point. So all the configuration of OSPF are going to be removed. So this one, for example, I still have rudder OSPF. I need to remove it. No rudder OSPF 1. So show IP protocol says that I have only ISIS, and this is what I need to do on almost every rudder. No rudder OSPF 1. So if I just check it, there is nothing. And no rudder OSPF 1. And if I again check it, there is nothing. And this is what I need to do, just to make sure that there is no leftover. No rudder OSPF 1. And here everything is going to be done just by, you know, executing some few commands. Okay, the next one is going to be to verify reachability, and of course I did it before I remove OSPF completely, but just to make sure, again, I'm going to make a few pings here, do a few pings here. So for example, from router 4 to router 10, I have full reachability, and I can source it from my other interfaces, and I have full reachability, and everything is finished. So this is one more time the steps of migration from one routing protocol to another routing protocol, and doing this to make sure that we convert smoothly without losing connectivity, without having any downtime.